All right, so, yes, we are live. Go ahead, say something. See if you catch that. All right. So, talking about multiplying polynomials. First thing we need to do is we need to identify what a polynomial is. All right. If we break down that word poly, all right, meaning many. That looks like mammy. All right, that's many. All right, and then nomial, if we break down nomial, that meaning term or terms. So polynomial is an expression with a certain number of terms, many terms or whatever it is. Polynomial is just a generic way to say it's a mathematic expression. But if we get more specifically, you have monomials. All right, mono meaning one, so one term. All right, that would be an expression like 3x is a monomial. 4x squared is a monomial. All right, 7x squared y is a monomial. It's just one term. Okay, if we go to the next one, you've got binomials. Yeah, who said it? Me. Jack, well done. Binomials means two nomials terms. All right. Bi being the suffix for two. You can see that in bicycle. It has two wheels. Bicentennial, all right, is every 200 years. You have bi-weekly. When you get older, you can get paid bi-weekly, and you can get paid every other week. So binomials are two terms. That would be something like 3x plus 2. All right. Notice it's two terms because they're separated by addition. All right. 4x squared minus 1. All right. 7x squared y plus 5x squared. All right. Those would all be examples of binomials. Now, next one. So here, next one, our last one here is trinomial. All right. Trinomial meaning three terms. All right, tri being tricycle, 3 wheels. Triceratops, 3 horns. All right, triathlon, 3 different events. All right, tri meaning 3, trinomial meaning 3 terms. So 3 terms, I'll just continue to add these. I'll say x squared plus 3x. That is a weird 3, sorry. 3x. Thank you for forgiving me. I feel so much better about myself. All right. So 3 terms, x squared plus 3x plus 2. What about 4x squared minus x minus 1? Those would be examples of trinomials. 3 terms. Terms are, again, separated by addition and subtraction. All right. So the number of terms in an expression is referred to as either monomial for 1, binomial for 2, trinomial for 3. And polynomials just refers to all of these. All right. Once you get to 4 terms, we don't go to quadnomial and pentanomial for 5. We just say they're polynomials at that point, and you can talk about how many terms they are. We specifically look at multiplying monomials and binomials. We'll look at that today. And we'll look at multiplying binomials with binomials to get trinomials. All right. And we'll look at those pieces and what it looks like when we go into multiplying polynomials. Let's go to our next one. All right, so as we do this, what you looked at yesterday was how to multiply 2 terms together that have variables. Let's just take something very simple. 3x times negative 2x. When I am multiplying 3x times negative 2x, I'm simply doing numbers times numbers, variables times variables. What I'm really seeing here is that all of these things are being multiplied together, which means I could rewrite this as 3 times x times negative 2. I'll put that in parentheses because it's negative. Times x. Multiplication is commutative, which means it can move around. So I could rewrite this as 3 times negative 2 times x times x. And if I do my numbers times numbers, 3 times negative 2 is? Negative 6. And x times x is? X squared. All right? So when I look at this, in the original here, when I have 3x times negative 2x, I just do numbers times numbers. 3 times negative 2 is negative 6. X times x is x squared. I do not expect you to show this whole piece of it. This is just why it works. All right, I expect you to go straight from here down to here. Okay? Any questions about that? All right, so let's take a look at 521. All right, 521 is specifically going to look at the distributive property. All right, 521 specifically looks at the distributive property, and it starts off with something very simple, just 6 times the group, negative 3x plus 2. Now, we want to look at what's in front of the parentheses when we distribute. This is 6 times the group, which means it's multiplied by everything inside that group. If I were to come up to a table, all right, like Ben's table here, and I said, hey guys, you know, you've been doing a really good job today. I'm going to give every single one of you guys some money. I'll get some money out. You might not be too excited because it's only pennies. But I'm like, you know what? Every single one of you is going to get some money. You guys are doing really good. I'm going to give a penny to give a penny to your entire group. And I go here, here, here. All right? What's up? Peyton, do you feel left out?
Yeah, Peyton's left out, isn't it?
For those of you listening to the video right now, I just gave 3 pennies out, 1 to Ben, 1 to Nate, and 1 to Pigeon. However, I did not give 1 to Jaden, who is also in the same team. Now we're hearing Jaden's reply.
I mean, you called me Peyton.
No. Is it Pigeon? Oh, Peyton?
He said Peyton.
Yeah. It's not like we have video record of this, all right? So silence. No, but what do you think? Jaden, why do you feel left out? You didn't get a penny, but why did you expect to get a penny?
Because you had another one in your hand and you gave one.
Oh, well, I don't have another one in my hand now.
But it's okay.
All right, but why did you expect to get one?
Because you said the whole table.
Because I said I'm giving it to the entire group. If I say I'm going to do something to the entire group and I don't do it to every member of that group, then something's wrong. Now, in this case here, we are saying that I am doing 6 times this entire group, negative 3x plus 2. That means I'm doing 6 times every term in that group. This is a monomial, 1 term, multiplied by a binomial, 2 terms, which means I have to do it to both terms. When I do that, I simply do numbers times numbers, variables times variables. 6 times negative 3 is negative 18. X times no more x's. There are no x's being distributed, so it just remains as x. All right, 6 times 2 is 12. And that's my final result, negative 18 plus 12. All right? Questions on that? Let's look at B. All right, in B, it gives me x times 4x minus 2. All right? And in this case here, now all of a sudden it's saying, all right, forget a number being multiplied through. Let's distribute a variable. But same thing, I have to take that monomial times both terms in my binomial. Now here, what is the coefficient of x when you don't see a number? It is 1. So it's 1x times 4x. Well, 1 times 4 is 4. X times x is x squared. 1 times negative 2 is negative 2. X times no x's is just x. All right? Now let's put it together in C. All of a sudden in C now we've got 5t. And we've got 10 minus 3t. So putting this together now we're going to do 5t, the monomial 5t, times the binomial 10 minus 3t. Again, do numbers times numbers, variables times variables. 5 times 10 is 50. All right? T times no t's stays as a t. Now do the next one. Numbers times numbers. 5 times negative 3 is negative 15. T times t is t squared. And that's my result. That's it. And then we'll do our final one. This shows our last example. In this case, it is a negative being distributed. So we've got a negative 4 going into 8 minus 6k plus y. Now, all of a sudden, we've got a monomial times a trinomial. All right, well, again, that monomial is just going to go to every single term. A trinomial has 3 terms, so it's 3 different problems. Numbers times numbers, variables times variables. Negative 4 times 8 is negative 32. Negative 4 times negative 6 is positive 24. The k didn't have any k's multiplied by it, so it just stays k. And then negative 4 times positive y is going to give me a negative 4y. A great way to double check your answer. A great way to double check your answer is to look. If you couldn't combine terms inside my parentheses, I'll do yellow here. If I couldn't combine terms inside my parentheses because they weren't like terms, I should not be able to combine them afterwards. If I couldn't combine them before I distributed, I should not be able to combine them afterwards. Same here, I couldn't combine these before, I can't combine them afterwards. Sometimes students will make a mistake with the variables, and they'll forget to put the squared, and they'll end up with a situation that they can combine. All right, that's how you know you did something wrong. If you can't combine before, you should not be able to combine afterwards. All right, now we're looking at 525a. Now we're doing binomials times binomials. This is primarily the way that I will be testing you on this skill called multiplying polynomials. The distributive property, what we just did, will mainly come in when you're solving equations. All right, and you'll see that. But when we really look at this, we're looking at binomial times binomial. The easiest way to multiply 2 binomials is to create what we call a generic rectangle. A generic rectangle will look very similar to what you've seen before with like lattice or area problems, where I can break apart the pieces of my problem using the dimensions of my rectangle. Now, if you'll notice, I did a 2 by 2 rectangle. Does anyone have any guess as to why I might have done a 2 by 2 rectangle? What do you think, Katie?
Because you have 2 terms, like,
Yeah.
on each side.
We have 2 terms in each. It's a binomial times a binomial. All right? So that means that one binomial is going to go on the side, and I'm going to put x at the bottom and positive 5 up top. Please notice I put the plus in front of the 5, not in between them. It will mess you up, and you'll mess that sign up if you put the plus between the 5 and the x there. Keep it with the 5 because it's a positive 5. The other one I will put down along the bottom. All right, and so I'll put 3x, and I'll put plus 2. If you had a trinomial, as you'll see in problem D, a binomial times a trinomial, then you do a 2 by 3 generic rectangle, and so on. Now, once we do this, we then see we've got our 2 binomials, and I can't multiply them as they are because I don't know what my x is, but I could multiply the individual areas of these 4 pieces of this rectangle. So I start with the bottom left, x times 3x. Well, numbers times numbers, that's 3 times 1 is 3. And x times x is x squared. All right? So these 2 combine in this box to multiply together to get 3x squared. In my top left box here, I can multiply 3x and 5. 3 times 5 is 15. And x times no x's is just x. My bottom right box, now I'm going to do x times 2. That gives me 2x. And then my top right, I'm going to do 5 times 2, which is a positive 10. All right, so we can see x times 2 gets me 2x. All right. We can see 5 times 3x got me 15x. All right. We can see 2 times 5 got me 10. All right. Those are the pieces that we're looking at. So as we look at this one here, now we've multiplied everything to get the interior, but we have to write our final expression. And if I want to write my final expression, I could just say that this equals, and I'm going to combine the like terms inside my box. Well, 3x squared can't be combined with anything else inside my box, but my 15x and my 2x these two can be combined together. And 15x plus 2x gives me a positive 17x. And then my last one, 10, can't be combined with anything else, so it's just left as 10. I do want you to write it in that order of x squared, x constant. This will be known as our standard form of a quadratic when we get to chapter 8. So get used to putting it in that form. And whenever we do this, the x's are the only ones in these typical ones that you can put together. But this would be my final answer. All right, so that's my final answer.